That is station 96139. And the PI is up here. The tangents, of course, run from the point up to the PI and then back down like so. And that tangent length was 52, the tangent length was 53.23. Okay, now there's some things we've got to get straight before we get going. Number one, let me tell you what we're going to do, and then hopefully I can explain how we do it. You're going to set your instrument right over here. Set up over the beginning of the curve. Okay, I'm going to look down the tangent line, and I'm going to set my instrument, my transit, so that it reads 0, 0, 0, and it's ready to turn to the right. So I'm set up over this hub, look down to the PI, set the angle to 0, 0, make sure the little button is going to the right or the display says HA. Okay, so I'm going to turn angles. And this is what we're going to do. It's pretty simple, but we need the data. We're going to turn an angle. We're going to look through that line, and we're going to measure a distance. So the angle is right there. So we're going to be calculating deflection angles. That's that angle. That gives us a line of sight. We're going to measure a long chord distance. The sight and the distance intersect at a point where we're going to place a stake. So I need to get myself in a position where I've got a series of angles and a series of dimensions that allow me to set the stake. So I'm going to erase this right now for a minute. So it looks like we need angles. The worst angle, the biggest angle we can possibly turn and stay on the curve is going to be an angle that goes from the tangent to the long chord. I'll be sitting here and I'll be looking right down this line, and it goes right through the end of the curve. That's the biggest angle. Now, if you try to figure that out and look at this picture over here, this is 90 degrees. Okay? If that's 90 degrees and this is I over 2, that means this inside angle is 90 degrees, which makes this angle right here 90 minus I over 2, because this plus this have to add up to 180. And now if I switch to this triangle right here, there to there to there, and this is 90, for that triangle to add up to 180, this angle right here has to be I over 2. So the biggest angle I can possibly turn is I over 2. So that's going to be what, 18.402? Okay, so it's going to range from 0 to I over 2, in our case, a little over 18 degrees. So now I need a table. So we've got everything set up the way I think we need it. I can get rid of that picture over there, and we can go about filling in our table. So this table is the table you're going to fill in for the lab on Thursday. We won't be, obviously, we won't be going outside. You won't be here, so this is the table we've got to populate. I'm going to show you how to populate it. You take the data out of this table, you take it to the field, and you lay out the curve. So if I look at this table, it looks like this. So I want you to copy this down. It's a fairly long table. This is the Excel spreadsheet table you're going to develop. The first is the station. The second column is delta L. Third column is L. Fourth column is D times delta L. Next column is D times L. The next column is the short chord. And the last column is the long chord. Okay, there's three terms there that I don't think you're familiar with. The D, the short chord, and the long chord. So I'm going to go ahead and we're going to populate it. I'm going to slowly go through the first calculation, and hopefully when we get done you'll understand. So this problem statement said, I'll read it. Set up field notes to lay out the curve at even 1/4 stations at the center line of the curve and the center line of the long chord. So I'm going to put a stake, a pin right here, center line of the long chord. I'm going to put a stake on the center line and then at each 25-foot stations. So if I look at this thing and I lay it out just physically, it looks like I'm starting at 910. I'm going to 961, so about 11 foot back is 9 plus 50. About 15 foot forward is 9 plus 25. Quarter stations, so I want the numbers to have 0, 25, 50, 75, or 100. So there's the first quarter station after 910. Then 25 more feet is quarter station. Then 11 feet to get to the center. It looks like the next pin is going to be about, 14 foot past there? 9 plus 75. And then I've got one 25 foot away. And then I've got one 12 more foot away. So now I've got, there's where each one of my pins are going to go, right here, here, and so on. So I put my stations over there, and I do it like this, beginning of the curve. I know where they're going, so I've got places to put them. 25 is next. 50 is next. 961.39 is next. 75 is next. 10 is next. Okay, and this is, of course, the end of the curve. And this is, of course, the center line of the curve. 61.39, excuse me, I screwed up here. 61.39. Okay, now we're going to get into explaining some things to you, hopefully that makes sense. The delta L is the dimension between adjacent stakes. So it's the dimension from here to here is first delta L. Here to here is the second. Here to here is third. Here to there is fourth, fifth, and sixth. So it's the increments between the stakes. First one is 15 feet. This will be a blank. 10 to 25 is 15 feet. 25 to 50 is 25 feet. 50 to 61.39 is 11.39 feet. The next one, this to this, is 13.61 feet. Next one is 25 feet. And the last one is 12.78 feet. Okay,